Now, let's read the question. Represent the complex number 2 plus 4i in trigonometric form. We already have the formulas on the top right that we're going to use. One of the pieces we need is the argument, or the theta, or the angle. So to show where the theta comes from, we're going to graph 2 plus 4i. First, we need to go 2 in the positive real direction, or right. Then we go 4 in the positive imaginary direction, or up. So now we know where 2 plus 4i is. Let's label our point. Normally, you don't put the black line, but that black line will help us with the next few steps. Now, let's label the angle we need to find. We go from the x-axis between quadrant 1 and quadrant 2 and go counterclockwise. The next piece we need to find is the modulus of r, or the distance that is formed from the origin to our point, which is the black line. First, let's solve for r. So let's write down the formula. Once again, r is equal to the square root of a squared plus b squared. A is 2 and b is 4, so now let's substitute that into the formula. Now let's square both numbers. 2 squared is 4, 4 squared is 16, so now we have the square root of 4 plus 16, and 4 plus 16 is 20. So now we have the square root of 20. Let's simplify the square root of 20. We can separate that into two radicals, so we have the square root of 4 times the square root of 5, and the square root of 4 is 2. So now we have r is equal to 2 times the square root of 5. What does that number even mean? Let's put that number in decimal form so we can have an idea. So the modulus of z, or r, is equal to 2 square root of 5, or 4.47. Now we need to find the argument, or theta, or the angle. Luckily for us, our point is in quadrant 1, so we only have one step to find theta. Since we have a right triangle, we can use tangent to find our missing theta. Remember, tangent is the opposite side length over the adjacent side length. Let's substitute 4, the opposite side length for b, and 2, the adjacent side length for a. So now we have tangent theta is equal to 4 over 2. And 4 over 2 is 2. So now we have tangent theta is equal to 2. Let's take the tangent inverse on both sides. So now we have theta is equal to tan inverse of 2, and tan inverse of 2 is 63.1 degrees. Now we have our r and our theta. Let's substitute what we have into the trigonometric form of z. So z is equal to 2 square root of 5 times the quantity of cosine 63.1 degrees plus I sine 63.1 degrees. And that is our answer for example 1.